Array is a built-in, non-primitive or compound data type in Java. Just like in C, C++, it is a fixed size, contiguous sequence of elements of the same type. Once allocated, the array size cannot be increased or decreased. Java arrays contain only items of the same type. Here is how we declare an array reference, the data type. We are going to store in the array the name of the array and the square bracket notation. This just declares a array reference, but no space for the array is allocated at this point. By the way, this is not possible in Java. So in C++, we used to say integer A5 that used to declare and allocate an array with 5 integers. This is not possible in Java. The other alternative syntax for declaring the reference is to use this, where we move the square bracket before the variable name and right after the data type. So it's just a matter of taste. But if you prefer this syntax, use it. But if you prefer this syntax, use this syntax. After declaring the object reference, we now have to explicitly allocate the space for the array elements. Here is how we allocate an array for 20 integers. This is very similar to object instantiation. So think of A being the array reference, and this is where we allocate the space. So anytime you use a new operator to allocate some space, be it an object or an array or anything else, this space for it is allocated on the heap, but the actual reference is on the stack. So it follows the same principle. That's why in Java, everything have to be allocated using the new operator. The other thing that's distinct from C, C++ is that all array elements are automatically initialized to 0 after the array is allocated, just like what happens during object instantiation. Remember, if you don't have a constructor, any constructors at all, the compiler automatically creates a default constructor for the object and initializes everything to 0. This is the same thing. So you allocate the space for the array, and all array elements are automatically allocated, automatically initialized to 0. In Java, arrays have a property called length that gives you the capacity of the array, the total number of elements you can store in this array. Remember, there is no such property in C++ or C arrays. So let me just go step by step and show you that this is going to print 20 because we just allocated an integer with that can hold up to 20 elements. There you go, the length is 20. To reference an array element, we use the square bracket operator, just like in C, C++. So because we allocated an array of size 20, the indices are from 0 to 19, just like in C, C++. So I can put 10 on slot or cell 0 and 100 on cell 19. And I can then print them out. So you can see that we just put 10 at cell 0, 100 at cell 19, and any other cell that we print will have 0. Remember, by default, all elements are initialized to 0. The other thing is Java does index checking. So if we were to write a code where we are accessing an invalid index in the array, this will throw a array out of bounds exception. So let me show you this. I'm just going to run it, and you're going to see that because at this point, at line 19, the runtime environment is going to throw an array out of bounds exception. All right, because we are accessing a element that does not exist in the array. This is not done in C, C++. So in C, C++, because the runtime environment doesn't do array bounds checking, this would have continued executing, but then your program might have crashed somewhere else, and these kinds of errors are very difficult to find. But Java does error bounds checking. That's why if you try to access a invalid index, the runtime environment is automatically terminate your program with array index out of bounds exception. Usually we would declare the array reference and allocate space at the same time in a single line like this. So you would never first declare the reference, array reference, and then allocate it on a separate line. You would usually combine them into a single line like this. So this is array B, which stores doubles, and we are allocating space for 50 doubles. You could also declare and initialize the array elements at the same time. So this is how you do it. I say integer c, this is the reference, and then I'm saying the array has these 6 elements. So the length of this array would be the number of elements in the initializer. The alternative notation, the syntax for it is this. This is the alternative syntax where we are saying allocate space for integers, and here is the initializer. But this is, a longer syntax, so you would typically prefer this syntax to the other syntax. And because the array elements are automatically initialized to these values, if we print them, if we print, 0, 2, and 5, we should see 5, 2 is 6, and then 5 is, 0, 1, 2, 3, 4, 5. That would be 9. Let me actually show that. So let me put a breakpoint in here and start the debug so that we see those values. So we are initializing an array of C, and we can see that. So these are the values. You can see them on the left hand side. So 0 is 5, 0 is 5, 2 is 6, and 5 is 9. Again, this is just to show you that it is possible to put the square bracket notation right after the data type and before the reference variable name. So this is the same thing as saying integer d square bracket is equal to 10, 20. Obviously, this is just an array that contains 2 elements. The first one is 10. The second element is. When we declare and create an array of objects, we are not creating the actual objects. We are just creating an array of object references. So in this example, I have a array S that stores strings, and I'm allocating 5 string references. So at this point, this array is just this is an array of object references, and all object references are initialized to 0, meaning null. So that there are no string objects created yet. It's just 5 object references. Next line creates a new string literal and stores the reference, its reference in S3. So now S3 is kind of pointing to John, and all the other object references are still null. Here's the actual code. I am allocating an array of 5 string object references and putting the reference to John, the string John, into S3. So I can print the length. The length is 5 of 5 string references. And I can print, S0 and S3. As you can see, S0 is null. S3 is pointing to John. That's why we are seeing John on the screen. But all the other object references like 0, 1, 2, and 4 are null because we did not allocate any string objects for those cells in the array. How do we iterate over the elements of an array? Here we declare an array of 5 elements and initialize them to 1, 2, 3, 4, 5. Obviously, the first way of iterating over the array elements is the for index loop. So we start at index 0, go all the way up to a dot length. A dot length is not a valid index in the array, so I has to be less than a dot length. So let's just add these values up and print them and add them up. So we're just printing them one by one on the screen and adding them up and printing the sum. So the sum of the numbers from 1 to 5, obviously, because that's what the array contains, is 15. The other alternative is called for each or for in loop. So here, this is the syntax. We say for, open parentheses, close parentheses, variable num or integer num, because I know that the array elements are integers. I could either use variable so that the compiler does type inferencing, or integer num. It's both meaning the same thing. And then a column and the array name. So this is like, hey array, give me your elements one at a time. So at each iteration of this loop, num will be equal to the next element in the array. This is actually using what's called the iterator design pattern in the background, although you don't see it. And we're going to talk about the iterator design pattern later on in the course. So here we are. The first element is 1 because that's the first element in the array. Then num becomes 2 because that's the second element in the array. Then it's 3, then 4, and then 5. So if bottom line is this, these are, both of them are valid ways, to iterate over the elements of the array. You would use the for index loop if you actually need the index. So if you want to know the index of the element that you're referring, then use this, this is the way that you should iterate over the elements. But if you're only interested in getting the array elements, but you don't care about what the index of that element is, then this is the cleaner version. So prefer the cleaner version, the for in loop, if you don't care about the index of the element that you're processing, and use the for index loop if you want to get both the elements and the index of that element in the array. Just like in C, C++, arrays are reference types. This means that if you pass an array as an argument to a method or function, then any changes made to the array inside the method or the function will be visible in the calling context. So here we have an example where we declare an array that contains 4 elements, and there is a function add5 that takes a one-dimensional array as a parameter and adds 5 to each element. Because arrays are reference data types, the changes that I make to this array will be visible in the calling environment. And let me show you this. This is the actual code. I am declaring an array of 4 elements and store them 1, 2, 3, 4. And now I am going into the array, the function. I'm passing this array into the function add5. And here are the elements. And I'm just going to add 5 to each element. So I'm adding 5 to the first element. It becomes 6. 5 to the second element, it becomes 7, then 8, and then 9. So when we return, you can see that the array that we passed into the function has also changed, because what we were actually passing into the function was not a copy of the array, but just the reference to the array. That's why any changes made to the array is visible. This is very similar to passing a object reference. Remember, objects are also passed by reference, meaning that any changes that you make to the object using that reference will be visible when we return from the function. In Java, it is possible to pass an arbitrary number of positional arguments to a method or function. To do that, we simply specify the method function prototype as follows. We say the data type, double, and then we put ... 3 dots after the data type, and then the variable name. What happens is you can now pass an arbitrary number of parameters. So in the first one, I'm calling sum with 2 arguments, 1 and 2. And in the second call to sum, I'm passing 4 values. So and in the third one, I'm passing actually 1, 2, 3, 4, 5, and 6 values. So what happens is when you pass these arbitrary number of arguments to the function, they are packed into an array. So we are referencing these arguments just like we are accessing an array elements. We're just using the for in loop to add them up and then return. This is very similar to what happens in Python. So for those of you who might be familiar with Python, the same concept also is available in Python. And here is the actual code. I have this function or method sum that takes a variable number of double parameters, and they are packed into an array. That's why I was able to access the elements in nums using the for in loop. And in the first call, I am making a call to sum, passing 2 arguments. There we are. So I'm passing 1 and 2. So if I go to the method or the function, you're going to see that they have been packed into an array. So this is an array that has 2 elements. I'm just going to walk over this using the for in loop and compute the sum. In the second call, I am passing 4 elements, as you can see. So I'm passing 1, 2, 3, 1, 2, 3, 4. So if I go there, now the array nums will contain 4 elements, and you can see that. So bottom line is, anytime you make a call like this, these arbitrary number of arguments are packed into an array, and that's how they're processed. So here we have an array that has now 6 elements because I'm passing 6 arbitrary positional arguments to the function. It's going to compute their sum and then print them on the screen. So it might be handy to have this notation so that you can implement methods that takes an arbitrary number of positional arguments. When we look at the prototype or signature of the main method of our app.java, we see that the main method takes an array of strings as arguments. This lets us pass arguments to our program from the command line. So we know that from C++, these are called command line arguments. So when we run our application using Java app, and then we're passing a sequence of command line arguments, these will be packed into an array of strings and passed to our program. So the command line arguments are actually widely used, especially when using command line to launch programs, to pass file names, options, etc. There is a difference though between C++ command line arguments and Java command line arguments. While C++ command line arguments have the name of the program as the first command line argument, in Java, the first command line argument is the first user supplied argument. So arg0 will contain the first user supplied argument, arg1 will be the first user supplied argument, and so on. This is different than C++. In C++, arguments 0 would be the name of the program that you're executing, and arg1 will be the first command line argument supplied by the user. But it's different in Java. In Java, the arguments are only the user supplied command line arguments. Here's a program where I'm going to run and pass a set of command line arguments. It just prints them on the screen, and here is the actual code for it. At the top of the program, we print the number of command line arguments passed by the user. If the command line arguments is equal to 0, then we exit. So we can exit our programs using system.exit and supplying a exit status. Otherwise, if there are command line arguments, it just prints them on the screen using a for index loop. So let me compile and run this program. So the way to compile our Java Pro programs is to say Java C app. Oh, I'm sorry. Should have said app.java. Then we run it using the JVM, say Java app. First of all, let me supply no command line arguments. So I'm just saying Java app. I did not supply any user, any arguments from the command line. That's why it says there are 0 command line arguments and then terminates the program. Let me now just pass, 1, 2, 3, and 4. So I'm passing 4 command line arguments. The first one is 1, the second one is 2, and the third one is 3, and the fourth one is 4. Remember, these are all strings, all right? So just because I'm passing integers doesn't mean that we're getting integers. These are just strings. And I can pass any arbitrary sequence of strings. So this is like the first argument, this is the second one, and this is the fourth one. So again, I have 4 command line arguments. This is the first one. This is the second one, this is the third one, and this is the fourth one.